actually saw this time that I didn't have any voice. Okay, so yeah, I added a class edge ID, which does as the two corners, left and left and right, whatever, on both sides of the edge, either sides. It comes with some kind of lexicographical random order. Should I say ordering? I don't think it's very relevant that I know which. I mean, the order is the lexicographical order is so random that the caller should not be not have to be aware of it. I think so. Might as well pass this as CI1, I think, and CI2, where the order then is no longer important. And then we'll store a low, as in the standard minimum of the two. And high is then the standard maximum of the two. So now the caller doesn't know anymore which one is the smaller one, but well, we still store it like that, so the assert still holds per definition now. Provided this compiles, I think it will compile if the corner index defines an less than operator. And it does, because it's a vector index which has that defined. Yeah. Which is also used here anyway. Okay, and then I have a face ID, which is a two-face of the hypercube. And as such, it has 4 corners. You pick where 2 of the coordinates are 0. Sorry, 2 coordinates are 0 or 1, of course. And here we store the corner where those 2 coordinates are 0. Cleared, as it says here. And dim 0 and dim 1 are the... Well, if I start numbering from 0 here now, maybe I should do that here as well. I don't really have a preference for starting at 0 or at 1, I must say, for stuff like this. Having, you know, just 2 arguments. but yeah, being consistent and stuff. Could also have renamed this to dim1 and dim2, but well, whatever. And then maybe I should do the same thing here, so instead of calling it dim1 and dim2. We want this to hold. So maybe again I should use standard min. Okay, so this comes from a corner index, which I think I named. I have a corner index of E0 here. And then independent of that, we make one from the F. Apparently I do not make a corner index from that. Yeah, it's kind of wrong, I suppose, then to run over ints here. And this should also be corner index. And I think that, well, in that case, I think I never have any corner. I'm just having the dimension. So F itself. I don't really care about those two corners. So for example, if we found S, then this is the edge. This is the corner index E0. This is corner index E1. And then for this face here, this rectangle, I only care about the direction being the dimension. So what changes here is the second coordinate between 0 and 1, and here as well, of course. So the index here would be 1. So this is index 0, this is index 1, so this direction is just 1, and I don't really care if we are here or there, and then, well, the other one is the other one, but we just change in this direction. What does that mean for face ID? I'm just going to call them E and F, I think. And then this is a bit doubtful. I mean, why would I care about storing the smaller one in one particular variable? Why not just store E here and F there always? Okay, yeah, right. Now we a face is a face, so if the same face must have the same face ID, always. Thus, if we have this example here again, this intersection point here, called FNS, belongs to the front face and to the bottom face. Well, let's talk about the front face. Then this is E, because this is the edge. And then this direction is F, that defines the fact that it is the front face. F would have been this direction if it would define the bottom face. Okay, so F is this one here, and then we talk about that face. However, this point here, called S, would have this as E, because now this is the edge. And then F would have been that one. But they both must end up pointing, well, having the same face ID, because it is the same face, and that's important here. So we do need an ordering between by the integer value rather than where they came from, E and F. So I can pass them as E and F upon construction, but not super relevant here, actually. So I think I'm indeed going to call them just dimension, but I do not really want to use the exact same words here. Well, before we call the low and high, I think that maybe it's the best thing. So I'm going to call them just enumeration. Like we have some dimension, we have another dimension, and then we are going to call those low and high, just like in the edge ID case. Though here I could just call it low. Well, I can call it low and high as well here, why not? Or I could call it dim low and dim high, I suppose. Is that more clear? Yeah, probably should have in the name that it is a dimension, because now it just looks like a face ID, a low face ID. So it is a dimension, and then the low one of that. Low and the high dimension. Called the smaller varying dimension. Yeah, and then this automatically holds, unless they are equal, but well, that would be a problem of the caller. Likewise, I can, yeah, I mean, I don't have to do that, leave that to the caller. You need to, might need, you know, I mean, I want to make the face ID itself unique for however we find it. My music is complete bullshit again. Okay, that's better. Oh yeah, man. So given a face, the face ID must be exactly equal to how, no matter how we find it, and we could have any pass any of the four corners. But I want to store something that is always the same in the base, so I just reset those bits, I think, instead of asserting it. I'm just gonna do base dot get value, and then reset those masks. So we do an AND with inverse. We're just doing this, clearing the bits for the dim 0 and 1, even before they are ordered, because well, if you if you would swap dim 0 and dim 1 here, then the resulting mask is still the same, so it doesn't matter. Got rid of the asserts. Let me check if it still compiles though. Typos maybe. Definitely some kind of typo, if you can call it that. No memory name dim 0. Yeah, I renamed those. So we order on low first. Dim 0 is now called dim low. How you should learn coding: by motivating yourself, by wanting to write a program, and then start writing the program, and then you will find yourself having a problem, and then you look up the information that you're missing. I think I spent 3 months, when I learned C++, I spent 3 months learning syntax. So without actually being, having a goal in terms of writing a program. And then I just started writing programs. Dim low, dim high. Yeah, I'm doing it all wrong. You distracted me. I'm doing it so wrong, it's unbelievable. Okay, now I have got it right, I think. The left hand side base is unequal to right hand side base, then we can compare those two. And if they are equal, then we do the same thing with dim low, left hand side or right hand side. If it is unequal, then I can compare it. Yep, and otherwise, well, we just left to the comparing the high one. Yep. Right, so let's go to the algorithm. Let's point out for you what is it doing. So we run over all axes actually. Yeah, now it's on. Well, before I have did this one at the top, so I swapped these two loops. It's somehow not as readable. Yeah, this is more like together. We run over all corners, and then per corner also over all axes. So from every corner, find all corners that we can reach from there directly by toggling a single bit of a single axis. Which axis? Well, this axis. So yeah. Yeah, it still kind of makes sense. We pick first the axis, and then we pick a corner, and then for the whatever the corner is, we consider the edge along this axis. So we're only really interested in edges that intersect with the hyperplane. So if this is not true, then everything is skipped and we just continue with the loop. I don't like an indentation. Well, in the enormous block of God knows how many lines. It's probably more readable by not having this indentation. And then instead do a continue here, just like we did in the previous case. If it is equal. So if both corners are on the same side of the hyperplane, well then the line between that is not crossing it. Let me skip it. And this is only working for the 2D case, so I should definitely get rid of it. Has fix me written all over it. Let's just begin with deleting it. And then I have F. And now I should be able to create the edge ID. Okay, record everything, make C tags, go back to the editor, edge ID, takes 2 corner indexes, indices, how do you say that? 0 and 1. Let's not do anything with it yet. I also want to create my face ID as soon as we can. And that should be here. Actually, no, think about it. The edge is the same for every face, so we should be able to do this earlier. At the very least before this loop here. And here now we add the F, so now we can do, we can add face ID. And that was created from a corner index, any corner index actually. We store it as base, but this is not necessarily base anymore. It's just one corner. A corner maybe. So I need just any corner. Well, obviously one of the corners of the edge is going to be one of the corners of the face. So we just use this one. That is the correct type. If I'm not mistaken, yeah, that is a corner index. It's also in the name, CI. And then you have to pass the 2 dimensions. Can't find tag pattern. Did that happen? Oh, because I renamed the A corner. No, whatever. So the 2, well, yeah, the 2 dimensions, that should be E and F in any order. call it this. The, okay, the, but then current. And then maybe here the same thing. ID for the, yeah, should be okay as well. Current edge. Maybe I can leave that in. Current edge. Into the columns. It's 8 fast enough. Okay, so both IDs are now there. Which is in principle, that's not enough, because next we're going to calculate stuff. I think the only thing I need is this, and then we can store that. Let's skip this example. We don't have this anymore. Now I want to store stuff. So here, store stuff, all the stuff that we just generated. And the idea is that also need to calculate the intersection. Still, do I want to do that here? This is per edge, right? Maybe we should move that above this loop here. You can store it in a map as function of edge ID. So having the edge by the ID of the edge, we can find back the intersection point. I think that should not be here. So I do that here, and then we cannot store it in intersections, because that's the output vector. We do that at the end. So we need something else here, probably a map. I just simply stores by some map here. Oops. That stores by edge ID. The intersection. This comment is more something that happens here after we saw that they are on different sides. Yeah. Shall we call this map? I think the name depends on what we store in it, and the intersection point is just one of the things that need to be stored in it. I don't really know yet. I'm gonna call it edges. It's a bit lame, but Yeah, I don't know, something, right? I don't know what goes into it yet. It's called edge data. So we have a map. It uses edge ID as the key, and we're going to store edge data. We call that just edges. I do think of what else I need to store in it. Just edges can't be enough. Just edge, I mean, just the intersection point can't be enough. Think of the list. Needs to contain a list of face IDs. Yeah. Which means that I need to have I need a reference. not just the face ID, also this boolean. I don't think I use face ID yet. I mean, well, here it says delay it because the whole thing must be moved down. Let's be lame and just rename edge data to current edge. That's maybe a bit too far-fetched though. That would only work if I rename edge data itself to edge, I think, and that's vague at the very least. I don't know. Maybe. Almost reads as English. Current edge store is entry point face ID. Yeah. It reads as the intersection point on the current edge is the entry point for the current face. Sort of. Good. Okay, no, that totally does not compile, of course. Plus, intersection is now empty. So, where do I fill that? Well, after we have done all that, then we have this map. So, here comes the code. Convert edges into intersections, and I can return intersections. But before I write that, I'm going to add edge itself. And I think edge. So this will default constructed, so I need a default constructor edge, and then I need to be able to update it later by calling that, and that is returns a void, doesn't return anything, and then store. We have this and store. Neither returns anything. And it takes this one takes a boolean and a face ID. Face ID is yeah, 128 bits. Let's just pass it as a const reference. And add intersection point takes whatever intersection is returning. Hyperplane intersection, which is a vector type. Vector type of, well, it is a math vector, but it can refer to the hyperplane, or maybe just the same thing as defined where we came from in the hyperblock. Looks like it. No, wait a minute. This is still hyperplane. This is hyperblock. And hyperblock has vector type with capitals. Jesus, why? Not very consistent. Let's rename that. I don't have the hyperblock defined yet, but no, we'll have to use this then. Oh, wait a minute. Yeah, apparently edge must be templated somehow. Let's just put it in hyperblock itself. Should work, I think. I didn't define them yet, so definitely not going to link, but I want to know if this compiles. Nope. Detail face ID, yeah, indeed. Expected semicolon after. Okay, whatever. Probably will compile. No. Oh, it's a private member. Yeah, I think I should just make it private actually. Make it a struct and then make the whole thing private. Be the private because it's kind of different from the member. Could put it at the bottom maybe. move it to the bottom for no reason. Yep, it worked. No link, but so now I have to implement these two. I would like to move them more down, but well, for now is put them here so that have everything in one place more or less. So these are member functions of Edge, and Edge itself is how do you call that? A subclass or something of hyperblock. It is a double A, no? Hyperblock, like that. And then I'm not sure it will pick up a vector type here. Let's try that. That would be the vector type also of the same hyperblock here. But maybe you can leave it exactly the way it was declared. Yep. That works. Okay, so we need to store the, well, a vector type. Let's add a vector type here then. Intersection point. Yeah, it's not a real vector. It's a mathematical vector. So I think that it's a good question what it is. Is a thing allocated or not? It's a math vector. No, it has hard-coded dimension. It's probably an array. Math vector. Cairowindow math vector. Eigentype. Okay, so it's an eigenmatrix, but I think an eigenmatrix with template parameters for the size is not allocated on the heap. So it is an array. So moving it does not make any sense. We just have to make a copy here. Could add an assert that it doesn't happen twice. So this intersection point must be undefined. Is that easy to detect? I don't think so, because default constructed thing probably just all zeros. Now I have to go back to vector again, math vector. Just depart from here. This is math vector. Yeah, the eigentype. I have no idea what that. If you default construct an eigentype, if it is not uninitialized, then it cannot be distinguished from something useful, or maybe it should never be all zeros, and it is initialized with all zeros. But I don't care. Just cross your fingers and hope we only get here once. And we also store this. Could store that in a vector, or we could store it in an array if I have a good idea of the size of that thing. And I do have a good idea of the size of the thing. Because the maximum number of faces is n-1. So maybe I should store here, I just have an array of standard pair, because I'm too lazy to make a new struct. Bool, comma, face ID. n-1. That thing needs a name. I'm gonna reverse it or not. That, you know, I wanted to have it in this order, so it was like readable in English. The is entry point of face ID, something like that. But here, I feel like having the boolean at the end for some reason. It's more like, okay, we're given a face ID. Oh, by the way, what is it an entry point or not? It's more like an afterthought. But on the other hand, exchanging these two things, yeah, I don't have good experiences with that. The thing is that the name that I have to make up here is, I'm tempted to call it primarily, or what is the word, by the first member, the data. So this would be something like entry point data with respect to the face ID. Instead of, if I swap them, you would just get face data or face info, or I don't know, something shorter. I like that more. I like short in this case. So let's reverse them. Otherwise, I cannot use that name, I think. I'm going to call this face info. And then the info is just that boolean. But the comment will explain it all. Always nice. The comment can be as long as you want. Unfortunately, storing it in an array demands that you also have a counter for how many things you actually stored in it. But I think it's still better than using a standard vector. I don't know. I don't really like doing heap allocations for that. I probably have to compare it to the size or so. Do you have to compare it with something? To compare it with n, I think. N is an int, right? So, yeah, forget it. If it can be an int, then it should be an int. So I'm going to use int. And, well, number of faces so far. So we initialize that with 0. It's important that it is 0. Because we begin with the default constructor and then we pretend that the array is empty, so we don't have any faces yet at all. And then here we can store the first one, face info, number of faces, and then afterwards increment it, post increment. Standard make pair. Okay, and now we have to make the pair in, well, in this order. First face ID, and then the boolean. And that function is a template function, extracts the types. I think it strips off the const reference. I'm gonna assume that it does that. Otherwise it wouldn't be able to store it, so we'll see. No, I think that works. You have it stored, right? I mean, if it compiles, it probably does what I want. Does not compile. There is a problem with pair. Called implicitly deleted default constructor. Edge. Ah. Yeah, I need that. We were relying on having it. Why was it deleted then? Slightly confused why it would be deleted. In instantiation function template specialization, standard pair mark detail edge ID math hyperblock to edge pair blah 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 requested. Oh, it's just requested. Requested here, 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 requested here. Default constructor of edge is implicitly deleted because field face info has a deleted default constructor. The problem is face info. And why is face info deleted? Default constructor of array standard pair math detail is implicitly deleted because field m elements has no default constructor. Are you telling me that standard pair has no default constructor? Or is it just because face ID has no default constructor? Of course it has a default constructor. I mean standard pair. How else could he ever make an array of standard pairs? So maybe detail face ID has no default constructor. That is the problem. Seems not unlikely. Absolutely random line number. Oh yeah, that does not have. If you add a constructor, then the compiler generated constructors are removed. So the default constructor is the this means compiler generated actually. So the default constructor is the normally generated compiler generated constructor. And yeah, we just need that to have an array with random stuff. Doesn't really matter what it is doing. I think it leaves these things uninitialized, and I'm totally happy with that. So this is a constructor uninitialized face ID. Okay, well, you're getting there, I think. I think that the last fix me, the rest should be working. There's no other fix me soon. Nope. Yeah, I think we begin with an edge ID. So we have edge ID. Yeah, I'll just call it edge ID. I was tempted to call it ID, but edge ID is the first edge ID. The first edge ID is just the random edge ID that has the smallest lexicographical value. I mean, this is the only map that we have. Oh, it's a bloody map. Oh, well then, yeah, I'll just take begin. So begin. Can this thing be empty, like at all? Suppose it will be empty, so there's no edges whatsoever that my hyperplane is cutting through. I think that is possible. It's probably possible. And then in that case I just want to return empty thing. So okay, we begin with if not empty edges. Then we do stuff. Yeah, is there no front or something? I mean, this is an iterator. I have to dereference it again. I don't think standard map has a front because, yeah, there is no really front or anything. But I'm gonna have a quick look what the standard map all has. Standard map has add. Yeah. Yeah, so we have begin. Yeah. I think we only have begin. It has to be begin, okay? Yeah, this is a hard part again. Even though all the data is now here. I asked an AI how to do this before. I didn't really read it because it was a bit vague. But on the other hand, maybe now I'll understand what it said. Let's see, where was my question here? This is my question. This is like my array size n-1, and it stores indeed it stores a face ink, whatever ink is. Incidents, face incidents. Okay, so in my case, this is a standard pair, and what the hell is this a vector then? Oh, that's just a point. This is the math vector. Yeah. So yeah, this is the same data as I have in my edge class, I think, including the number of faces. Makes a vector of those things. I have a map. It stores it separately. Yeah, I stored it in this map actually. So I don't know. Section index. I stored per edge ID an index into a vector with that data. Basically the same thing, I guess. For each crossing edge, look up / insert an intersection record. So I already did that. This is just storing stuff. So I think we can read this as blah. Storing it. For each two-face containing that edge, compute the inward face normal in your normalized type. You suddenly understand why I skipped reading this. Is it compute face ID? Nah. The geometric intersection point P is computed exactly once. Well, that was already the case in the old code. All face level entry exit information is attached to that one record. Yep, I have that as well in my setup now. Per face segments. For building the global order. Once you have intersections, build a face segment map. Phase 2 segment. Each face intersected generally will have exactly 2 intersection points. Your entry/exit classification gives the oriented segment. Okay, so it has a map with face ID as the key, and we have to fill that first. And that contains I could just put edge IDs in it, I think. So two edge IDs. One for the entry and one for the exit. I have to fill that. Now each face ID that actually participates in the intersection carries a directed edge of the intersection polygon in 3D. Or the single segment in 2D from entry to exit. Yeah. Okay, let's stop here and implement that. So then we are at 4. What comes after 4? 4, 5. And then it's done. Okay. I think I want to make a map from face ID to the 2 edge IDs. That's part of it. It's calling it segment here. What the hell is a segment? Because it's 2 of those things. No. Oops. I don't know about the name, but maybe we should just copy it. Yeah, okay, a segment is it's like this line here. So if this is a two-face, then the line inside the two-face is called a segment. So every face has a segment like that. And that segment is then determined by of course, the start and the end edges. Well, intersection points, but also edge, because every edge has only one intersection point. So you might as well say this edge, from this edge to that edge by ID. And then we have this segment. This is another thing that really has to be added inside the hyperblock. I don't think so. So every time you have a new pair, face ID, edge ID pair, we can fill in something in face segments. I don't have to do that afterwards. I can do that on the go. And the edge ID is always created first. Here. And then we create face IDs here. So now I have a new pair. And then for that face ID, I'm going to add the edge, which is edge ID. And that function needs to know if this is the enter point or not. So by edge, let me just remove this edge, add edge ID entry point. Hello, 707. Remember, this is actually the same thing as here, but then in a different way. Well, you will be surprised what is up. I'm coding. Remember, what shall we remember here? Yeah, something like that. So now I need an add for edge ID and boolean to whatever is stored in face segments. Something with a struct. Construct. I'm every time feeling that I want to remove this is here. Well, maybe not every time. Just entry point or bool entry point. I mean, yeah, what is the is doing there? Here I want to have the is. That's where it came from. And I don't like to have the same variable basically, because you just make a copy of it by passing it. Have different names. So if it has a certain name here, why would it have a different name inside the function? It's a really difficult decision. Nah, I don't know. Yeah, I'm gonna do it like this. What was this thing called? Struct face segment, right? Yep. So I suppose I could add, I could make it a class and add some restrictions that enforce a good state, like I did in the class here. In case, you know, something goes wrong, then I rather have it assert than that mysterious things happen. Oh no, this thing needs a default constructor. Starts to get annoying. That is the problem. It's storing stuff in maps, I think. Well, actually, it is just a map, so nothing is stored until I store it. Can I just construct it in place? Oh no, because I only know one edge at a time. So the first time we create it, and then I assign it partially. So we have an uninitialized edge ID concept here. Just call an index. Call an index is a but that has the concept of an being uninitialized. By default construct this thing, it gets a value of -1, which means that it is undefined. You can even test that if it is defined or not. So using a default constructor, default constructed corner index is supported in that it is then undefined, known to be undefined. So I could add a default constructor here. Which means that we can do that for both here. I'm gonna make it a class. Which then in the end means that this must be called for both entry point and and exit point. Now we can test if that is the case, because there's going to have an accessor here, two accessors. Yeah, well, those things are now private. So entry point, which returns the entry point, and now I can add an assert here. And the assert tests that it is not undefined. Undefined was for the vector index here. We have undefined, okay, and that must obviously be not undefined. And if it is undefined, then the comment is every assert gets a comment, as you know. What is the comment? The comment is call add for the entry point. Okay, so now we have filled the face segments map, I hope. And then we can do this stuff. I'm just gonna check if it compiles, I think. Compiles and then read the AI and stuff again. No member named undefined. What the hell? Detail edge ID. Oh, it's just an edge ID. Sucks. No, it doesn't not really suck. Let's see. Edge ID. Yeah, let's just add an bool undefined here as well then. Bool undefined. I guess we still have a compiler generated assignment, which will just make a copy both, meaning that if we assign this thing and we assign one of them away from undefined, then the assignment will be from another edge ID, meaning that it's not possible that only one of them is undefined. So, we can just test only one. Just testing just low would be enough. Provided that if we construct a thing, then it must never be unbalanced, as in these two always have both to be defined. And let's say I would call standard min here. Both would be undefined, and the less than works, then this would be just undefined. So that is definitely not good. Provided that the less than works while it is undefined. Let me see if that. I think that it's not testing anything. This is my feeling. See, less than just compares less than. It doesn't care if one of these values is -1 or not. But we have to do that ourselves, meaning if this is being called, then, well, I should probably afterwards, well, I can only do that afterwards in the body of the constructor. Test that both are now defined. And I only have undefined, so it is not undefined and it is not undefined. Which then means that they're both undefined or both not undefined, and then after assignment again both not undefined. So I really only have to test one here. Maybe, now I think about it, I should make sure that we never use operator less than on an undefined one. I mean, that would be at the very least weird, and I have to think about if that is acceptable. This is a friendo. So what do you do that the left hand side is not undefined and the right hand side is not undefined, which then in turn calls this again. I did not address that error. No viable conversion from standard pair const. This removed the reference but not const. Detail edge ID. Well, I did use standard make pair. I think the const actually comes from the map. Okay, let's look at the error again. No viable conversion from standard pair const edge ID hyperblock to edge. to edge ID. Oh, it's even worse than that. It's nothing to do with the const. Okay, now what? Might as well begin with the lexicographically smallest face ID. Now I think about it. Why wouldn't I? I think the face ID is ordered by the edge IDs. So kind of the same thing probably. If I go directly to the face IDs. So face ID, the face ID looks like at the base. Yeah, wait, but no, well, wait a minute. One of the corners, okay. This compares. The face has of course 4 corners. Then one of the corners has 2 zeros at the coordinates that change for the 4 corners. That is then also the lexicographically smallest corner of the 4 corners that are part of the face. And that is being used here to compare. So in the end, we pick the face here that has the smallest. One of the corners is the smallest lexicographically. If the base is equal, then we sort very randomly on the smallest dimension. Let me digest that. think that's actually correct. Yeah. The smallest. That means that the next smallest corner is the smallest. And that's probably what I want. And what does it mean if these are not unequal? And the same bit is toggled there, but the next smallest one is then equal, yeah? And then the next smallest one top of that is just the high one, yeah. This is, yeah, so this is more or less sorting by corner ID, as if the four corners were the 4 digits of well, yeah, well, 2 to the power n is decimal notation or something. I'm gonna begin with the smallest face heading. That must be the face segments. The bottom line is that I think that the face segment belonging to that face ID will have an entry point edge ID that is the actual graphically smallest corner index. No, that doesn't have to be the case. Yeah, I agree with this, I think. So we have to run over all faces here. And then find the faces where that point is the, I would say, entry point. Yeah, vector 1, where this point is classified as entry. Except that we could have multiple of them. Then I suppose we'll just take the lexicographically smallest one. I think for the higher dimensions, I still have no clue if it will work, or how it should work even. I am not convinced. Hello, Routine Alice. And EZG, oh, I already said something to you. 707 was that. Let's say, add, you can walk the cycle using the incidence information at current index coming from phase, on coming from phase segment is entry to exit. If you arrived at current index as entry, move to exit, else move to entry. The new intersection index, pick the other phase. To be this intersection index, append intersection that point to the result vector. Okay, blah, 5. Why the skills for n is larger than 3 structurally, even though conceptually ordering is less intuitive for higher n, the same storage pattern still works. Intersection record, it's still 1 per edge. Each intersection belongs to n minus 1 two phases. Phases just gets longer. Phase ID and phase segment are unchanged. The graph of intersections plus phase segments becomes more than too regular, so the traversal logic needs extra rules. E.g., always choose the next phase consistent with advancing along the hyperplane direction. But you don't have to change how to store data. So in short, use a per edge intersection record key to a canonical edge ID with a small array. Phase ID is entry. Incidences, whatever, plus a phase ID to entry exit map. That gives you one intersection computation per edge. Yeah, local per phase entry exit classification, a clean deterministic way to assemble the final ordered intersection list by sorting traversing purely on edge ID and phase adjacency. I think it's been very incomplete there, and I doubt that it is correct actually. It's damn hard to visualize. I pride myself that I can visualize 4D more or less, but a tesseract. Okay, so we have a tesseract. We cut a tesseract with a volume, a 3D volume, through, gives intersection points on edges, find an edge. Every edge is part of 3 two phases. Now, let's say we already came in from one of the phases. Yeah, now we have 2 possibilities. It's I did make a drawing of a tesseract. Where's that? Grab it. Yes, here it is. I had my phone. I have my phone. Okay, I can make a picture of it and show it. Picture. It's a bit dark here. Still dark. Let's go to here and then Zargar said saved messages, I guess. Picture. Looks like a no, I think that worked. Blub, 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 blub. There it is. That is my tesseract. So for example, this point here is so this is a four-dimensional hypercube, a tesseract, which has well 16 corners, where each corner has 4 coordinates, either 0 or 1. And so 2 to the power 2 is, 2 to the power 4 is 16 corners, labeled 0, 0, 0, 0 to 1, 1, 1, 1. If you cut through that with some volume, then it intersects with the edges. And I did draw in one such volume. So here it intersects with this edge here, and with this edge here, and then with this edge here, and with this edge here, and with this edge, and this edge, and this edge. Yep. So if we find one of the edges, let's say this one, then you see that now, unlike in the cube case, we have 3 two faces that are part of this edge. Namely the orange one and the green one, like it would be for this cube here, this cube. But also this one here, the green thing. So this one is, well, the thing is blue here, but it's not part of it, is it? No, actually it is. In the background. So it's part of 3 cubes. The green cube, the blue cube, and the orange cube. But every time two cubes share one face, so in the end we end up with 6 divided by 2 is 3 faces. And I shaded them, so we have, well, apart from the, well, actually it is shaded. It's a bit, it's hard to see on the picture, but this one is shaded blue. What the hell? What's my washing line? I made a washing line that is, yeah, well, I'm a perfectionist, so what can I say? We're not about that here. No, let's see. Yeah, so this point is in the edge here is has one intersection point, but we have 3 two faces. This one, and this one. And then the question is, in which order do we give the intersection points? Now, say we are here, because that is, I don't know. Actually, let's begin where we should begin. This one. This one is lexicographically the smallest per definition, because, well, this corner is the smallest and that is the next smallest one. And it's on that edge. So this one is definitely going to be the first one. And then this one has is part of also 3 faces. Let's see if we can find them. That would be this face, obviously. And this face. And there must be a 3rd face. For some reason I did not draw the orange line that comes from that one. It must be this one, right? Well, that would be this line. This line cuts through this. This is the segment that belongs to this 2 face. And this is the segment that belongs to this 2 face. So the bottom one here. Well, I don't know. I see a bottom here. Where is that being cut in? Should be cut as well. I think I did not add all the intersection points. I'm afraid. I think I gave up halfway, and then I decided to write a C++ program to do this. Yeah, even where I can rotate it. Yeah, and that was the situation. So I have a half-written program that allows me to change sliders, and then the tesseract should be rotated in 4 dimensions, and it should the volume can be moved around and rotated, and the tesseract itself can be rotated, and then it would continuously draw this with all the intersection points and all the segments in. That was my intention. Well, I had forgotten I was doing that or started to work on that. Now I remember. I think I should not finish that. It's just too much time. I have to go back to what I was really working on. So yeah, this corner is incomplete. Let's just go here, because now at least we have the 3 two faces. And it's just totally not determinable which edge to follow first. I think I could ignore 1 dimension and then just follow the 3D cube. For example, I mean, it's likely that we want to ignore the cubes that have 1, 1, 1, 1 in it. That seems very big, very high. Which would be the blue and the orange one. So yeah, it's this one that we want to do first. And then it's easy. We just have to follow this line, and then this line, this line, this line, and this line, and then we are back. And now we have no other option than to follow, yeah, one of the other directions. And I already have two, so there's only one direction left. So I can go there. See, that's a dead end. Because, I mean, it could go here, but that is a dead end. Or you can go there. And then follow this cube, and then we reach a point that we already visited. So it's definitely a graph problem. We'd have to make turn this into a graph and then use some kind of algorithm that keeps track of which node has been visited. And then on top of that, make it such that it is deterministic, aka always the same. Predictable stuff. I don't want to do that. I don't have time for that. On the other hand, is it true that no, because I'm missing stuff. Damn it! I have to really finish this picture because it is before the usual. I think every point needs to have 3 segments. Currently, this one has 3 segments. This one has. This one has. That one, and that one do not. Can just look at cubes as well. How many cubes are there in a tesseract? I guess the way you build it, you have a cube and then you lift it into the 4th dimension, so then you have 2 cubes. And at the same time, every of the 6 squares form a new cube. So in total, 8 cubes. Probably 2 in. Yeah, of course. You have a cube is an outside, so you have 2 times the number of axes outside. So we have 4 cubes, 8 cubes. And every cube has a polygon in it. Should have a polygon in it. For example, this cube here, this one, yeah, you see it, has this triangle here as the polygon. While this cube has this 5 thing. So 1, 2, 3, 4, 5. Polygon with 5 corners. And this one is also 5, I think. So this cube here as this one in as a polygon in it. So I did only 3 of the 8. And we try to find another cube. For example, this cube here. Which face of that one did we already do? Just this one. I think, yeah. So difficult. I think I need at least one more intersection point before I can draw the whole polygon in it. How did I find out the others? I just made them up, I think. Oh, maybe it's just a degree of freedom again. Ah, you think so? Could be. Let's say in this, so in this cube here. Oh, the thing suddenly turned inside out. Yeah, doesn't matter. So we have this one, and then wait a minute, does that not matter? It should not matter. No, it should not matter. This one, I mean, there should be an edge in this two-face here. So those 4. That edge must be parallel to this line, because they're opposite planes, or parallel planes. That we don't have an, if I had, say, an intersection point here, then I could just draw a line that is parallel to that one, and then we would also find an intersection point here. But you don't have any. Maybe we can just pick any random place. There's a degree of freedom that we have still. I'm wondering if that is the case. Maybe it's not. Now this face here is also part of this cube, which means that whatever line is in this direction here must also be parallel to that one. So that one and that one must be parallel, and they are. And this one as well. They're all parallel. You see that? So just this one is missing. And I guess this one is parallel to that one, and to, well, this face, which does not exist yet. And what other cubes do we have? It's only two cubes per face. Yeah. No, must be 3 or not. No, it's 3 per edge. It's 2 per face. Yeah. What the hell did I get? 4 parallel. Oh, these are just completely disjunct. Well, yeah. The whole shape is even the same, see? This cube here. Exactly the same shape as that one. So likewise, this big one here, same as that one. Thus, a line like the thing has only one line in it. This one, that must be parallel to that one. Yeah, so it's the same thing again. I don't know. It's not easy. To kill this, you know. T, nope. Undo, nope. That'll work for 2Ds, for 2 dimensions. something I don't get. If into 4D case. My problem is that if come on, man. What the hell? No, apparently it doesn't want to zoom in a little bit. So I thought all this time that if you take one of the cubes that is on the outside of a tesseract, for example this cube, that cube would just behave as if it is a 3D cube. Meaning that each segment has a direction such that you go in a loop. Which in turn means that every face, when looked from the outside in this 3D volume where this cube lives in, the edges have a clockwise direction for this face. So if you look at this, the green face from this side, it goes clockwise like that. meaning that the direction of this one, you know, let's follow the clockwise direction of the green face like this, yeah. So then we cross this point, and then we go there, and then we go there, and we go there. So that means that we must be able to make a loop like that. Think, wait a minute, that's not true, because if you go like this, you would say we can go like that. Yeah, sorry, that's to do with the normal, of the cutting plane. So this 5 polygon here is 5 corners. Is if that has a defined normal that points towards us. So we look at the orange polygon here from the side from which the normal is pointing towards us, then that direction forms the loop. So on this side we have this loop. And this is on the other side of that plane. Therefore the loop here is the other way. So the direction is still this direction. It doesn't go like this or like this. So this edge has a direction that goes like this, and this has a direction goes like this, and this has a direction that goes like this. Every time clockwise when looked from the outside. So then back to the tesseract. That means that well, since every two-face is a face of 2 cubes, this cube shares the same face with that cube, but the direction was already determined. Well, we said that our direction was like this. I would think that it means that this whole cube has to be inverted, right? So now if you look at this face of this cube, it's anti-clockwise. If you look at it from this side, then it still rotates the same way, so that would be anti-clockwise. And that I thought, well, that probably holds for every face. Also, this one would be anti-clockwise, and this one anti-clockwise, and this one anti-clockwise. But it's not that easy, because there is a cube here that shares a face with this cube here, and it shares a face with that cube here. Ouch. So my whole story collapses. I can't have all the faces be clockwise here and then do anti-clockwise for this one, because that would mean that this one would rotate like that, which is clockwise for this one. So there's going to be one face that has different directions depending on the cube that you look at. I'm so confused. Because the answer lies in the fact that it now is a volume that is cutting this thing. It's not the same plane. This is a plane, but then this edge here is cut by a different plane, namely this plane. And this plane is probably perpendicular to that plane. So there is no necessary relationship for the direction per 3D cube. Four dimensions are hard, yeah. Anyway, I was thinking I probably should use two arrays here. Which is what I'm going to do. So instead of calling this face info, well, instead of storing pairs, I'm going to store just face IDs. I bet this can be just divided by 2, or rounded up or something, or maybe even I can know in advance what it is. There's no loop here. But compose. So the first intersection point, and then run over all faces for which the current edge is an entry point. Then for each face we have to find exit point. Let's call this one ether as well, I guess. Does it even compile? Yeah, that compiles. I'm surprised. Oh, this is a bloody map. I thought it was a set. Yeah, of course. No, okay. So it returns a face segment. Should probably store it as a reference. Point and exit point. What to find next? Yeah, I think that here we need to recursively go back to this point. So it couldn't be a loop. It has to be a recursive function call. Yeah, that would be a depth first. I would rather do a, how is it called? Breadth first. I have no idea how that is called. Let's look that up. I actually typed it correctly. It's not really a need to use standard function, is it? I can just pass intersections. I'm implementing that first, but then I'll ask the AI to fix it. So I'm kind of lazy here, maybe, but... What? What did I do? This has to go to hyperblock. Struct edge. It's in the end and private. Okay, this is also private, but different private. Totally different. So, whatever. Wait, what? What? Never mind. No face segments. Ooh. Ah. And edges. But none of them exists. You have to boss them around. Beats me what that was. HID edge. Edges of face segments. Of course there isn't. Mm-hmm. Mm-hmm. Yeah, this is XML, so it's just amp in it and stuff like that. Less than, but okay. We can more or less see what AI is doing. Apparently just looking at the code. It now looked at the breadth first, so there's just enough information to fix it, I think. I don't think I see yet applied diffs in this window. Let's keep an eye on. Yeah, there's the div. It's already done. Added a queue include, rewrote hyperblock breadth first search to a true breadth first search. Iterative queue, process each edge once, and queue unvisited exit edges from all entry phases and preserve visited checks. Well, okay, apparently it used needed, I mean, a queue. Everything's done in that one function. I think it's easier to just look at the function. Oops, it's still open. Doesn't matter. There we are. It pushes to the queue and pointer to the current edge. It is totally safe because, well, there's an element of a standard map. I don't think elements would even be moved in memory, but the map is treated as const. It's even passed as const. So yeah, it's totally okay to use pointers there. So we have in the queue a pointer to the current edge, and then it says, while the queue is not empty, do stuff. I have no idea how the breadth first really works. I mean, I do have an idea. The visualization we had here, that tells you exactly how it works. This one. So for each node, we need to find all the children. So do this node, find both children. Then for the first node, find both children, and the second node, find the children. And only then start to traverse the children. I'm not sure what it is storing in the queue though. I'm guessing that what is storing in the queue are the gray things. So for example, at this point, you get 4 things in the queue, and then it starts to process it. So black means processing the queue, and gray means filling the queue. Yeah. So with that in mind, we begin with putting the first one in the queue, because it begins with making a gray. And then it starts to process the queue. While the queue is not empty, process the queue. What is that doing? That gets me the front of the queue, removes that. So now we have the first gray thing. If it is visited, well, then we don't want to touch it, so that would be a continue, I suppose. otherwise process it, that would be making it black, I guess. Just putting the in and really process it, yeah. Put the intersection point in it, which means that now it is visited. And then at the same time, we want to queue all the children. So using a single queue. Okay. Run over all entry faces of the edge, which is what he just marked. And then do the same stuff that I did. Except here, if not visited, then we push it into the queue. Yeah, I guess it's okay. Cannot totally wrap my head around it yet. Yeah, okay, I get it. So back here, indeed, we find that one, and then at the moment it processes it appends to the queue. So that means that this one is processed next, and that one is processed next, because they are just both added to the queue. And at the moment that this one is processed, this is added, these two are added to the queue, and that one is processed next, so then these are added to the queue. So then we get those four. And then finally that one. This is exactly what it should do, yeah. Probably also compiles. AI is pretty good in writing code that compiles. I don't think I haven't ever run into, I have not run into for a long time, it went anyway, that it did not compile. Yeah, no, theoretically I should test this, but I don't even know how. Feeling suddenly very lazy. So anyway, I can quickly test this. I think I'm gonna ask the AI to do that. Just write a quick problem that at least sees if it doesn't crash. I mean, I'm not even going to check if the order is correct, I think. But, nah, maybe for a 3D case. It's hyperblock. Why is there 0 hyperblocks? It doesn't make any sense whatsoever. One word? So, one word. It's not even a single test here. Okay, would I have to go to the math test suite instead of transform? I did already push it, right? Yeah. Let's go to math test suite. Hyperblock tests. I think you can just switch projects and still talk to the same AI instance with the same chat. Except that it will be very confused that suddenly the project is changed. Or maybe it will not be confused. I don't know. Let's see what this thing is doing in terms of tests. Yeah, this thing is calling intersection points. Is that not what I just terribly changed? Yeah. So the order of this vector has, well, potentially changed. Requires same points. Maybe that just doesn't care about the order. No, it sorts both, so it does not care about the order. So if I comment this out, how many times do we do that? Only here, that's good. Okay, so I do not sort the thing anymore, because now the order should be sorted out. Then yeah, that should fail, because whatever we have, whatever I'm comparing it with is expected reference intersections. Okay, those are probably returning something totally different. What is this doing? Yeah, okay, well, whatever. I think that is definitely going to crash. Hyperbook test failed. Nexus aligned slice test intersections. Index 1 expected 104, goal 130. Yeah, I don't even get this. It looks like the normal points in the x direction. And how is that giving this many... it should cut four edges of a normal cube. I think it's a normal cube. Maybe I'm interpreting this wrong. Maybe it's 1, 2, 3, 4 in total. Let's just print them. This buzz. So someone is calling this function, and then the result, the output, I want to print the output. Oh, it's already wrong here. This one is not generated. You can put this in the correct order. 2, 3, 4. Okay, so I have the corner at 0, 0, 0. And the opposite corner 2, 3, 4. And we are cutting it with the plane, and that has a normal in the x direction and goes through the point, I think, 1, 0, 0. So look at what the hell make plane is doing. Yeah, minus normal dot point, so that is actually the point where it goes through. Well, that would cut in x equals 1, so yeah, that's what it is doing. And then the other coordinates are equal, I guess, to every combination of the rest. So 0, 0, 0, 4, 3, 0, and 3, 4, yes. But what is the correct order? Well, the order is... Can I do this in my head? Ah! Yes, I can do it in my head. And the lexicographically smallest edge is the edge that is cut near 0, 0, which means that, well, 0, 0, 0, but I was so lazy that I stopped after 2 zeros. Which would be this one, obviously. So that is the first one. And then we have to go, well, the normal points that way, so on the side of the normal, so the direction is like that. Is that true? Well, I'm almost seeing it, but I just need a quick look here. So this is a block is like this. This thing is like that, and then the normal points that way, which means that I think the direction here is that way. Damn it, I have no idea. How did it work again? Why is this the direction and this from here to there? Because this is the first point on the front face, and it is the first point because because this one points in the same direction as the normal. And this is that way because it's clockwise like that. I think that's how it worked. So now we have something where the normal is pointing the other way, which means that it's not the first point on this face. This is the first point then, therefore. So we go down. And then like that. So after that one, you have to go there. But what is there? is a good question. Well, I imagined that X was here, and I think that Y had to be here, right? Otherwise, if you put Y here, this is 0, this is 0, 0, 0, and this is 1, 0, 0. You can see that here. This is how it has to be. So we have 0, 0, 0 here and 1, 0, 0 there. And this is 0, 1, 0. That means that this is indeed the y-axis. So we have to cross to the other side along the y-axis, which means that this one is the second one. And then we go up, which means that we have that one, and then we have the last one. So like that. Yep, this is the correct order. So if we now run it again, this test should not fail. The axis aligned slice test. Axis aligned slice test did fail. Yep, it succeeds. The next one that fails is the diagonal slice test. Let's see if I can do that one from my head. Probably get better and better at it. Okay, maybe I should make a drawing. Because definitely should make a drawing. Okay, we have a cube 0, 0, 0, 2, 2, 2. That's easy enough. I'm really going to draw this, I think. Well, you can use this cube. Okay, and then my plane has normal 1, 1, 1 going through 1, 1, 1. What? That doesn't look correct. Oh, it's a 2, 2. It's a 2, 2, 2. Yeah, so this is center. So this is the thing that goes to the center, and the normal is pointing to this corner here, which is 1, 1, 1. Which means that it cuts through here and here and here and here and here and here. Did I say that correctly? Yeah. 1, 2, 3, and then a little bit further. 2, 1, 2. I don't want to draw in it, but on the other hand, I can erase it again afterwards. So if you have a plane like here, when you move it along this diagonal, then the intersection points are on these 3 lines, and they move until you hit these corners at the same time, of course, those 3. Now if you move it a little bit further, then this splits into 2, and you hit it. Certainly if you use the center, it must be symmetrical. So we get there, 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 yeah. No, the last one doesn't want to. Absolutely not visible. I had a better drawing at some point. But yeah, it doesn't matter. So the lexicographical smallest edge is the Z must be 0 for sure. Probably the Y as well. Oh no, wait a minute. we cannot just change X. Yeah, we can just change X here, this one, but I don't know. No, that is not, yeah, that is X actually. So here, but this is not cut. This one then. Nah. Now, come on. We start at 0, 0, 0, and there is no edge that is being cut. Then we go to 0, 0, 1, and now there is only 2 edges that are being cut. And the smallest of that is, well, this one is 5, and this one is 3, so this one is the smallest. So this is the first one, and that is at 0, 1, 2. So the last one is actually the first one. And then we have to determine the order, the correct order in which we go. So you can use the top face, whatever, for the example. And then the normal is pointing that way. So more or less in this direction. Which means that what did I mean again? That means that this is the first point, yeah, of the top one. So the direction is going from here to there. So go around like this. So the next point is then here, which is at point 102. Hopefully this is correct, because otherwise you have to do it all over again. Let me double check it. Yeah, the F, it's the first point if the normal points in the same direction as the segment direction. The segment direction of the top thing is the purple arrow, so that is that way. The normal is the same way, so this is the entry point of the top thing. So the exit point is here. And then we go there, which then is 201. And then we go here, which is 210. It's already there. And then we go there, which is 120. Also already there. And then the last one would be here, which is 021. Yeah, so this should be correct. If I had a comma there. So you're thinking, no, this guy is nuts, he's doing all kinds of nonsense. But now you have to admit that I know what I'm doing. Except that it is wrong, apparently. No, diagonal slide test still fails, really? Damn it. 012 got 210. Oh, the first one is wrong. It says say that again. 210. 210. It says that this is the lexicographically smallest edge ID. Explain. Oh, damn it. I reversed the thing. Yeah, I read this as 1, but it is actually 4. The bits are reversed. Because, well, I'm calling it XYZ, and X is actually index 0. So, yeah. I should have read it as X, Y, Z, which means that the X and the Z have to be inverted. Is that all, or that might also change the rotation order or something? Let's just reinterpret it as this being 1 and stuff. So then, yeah, the 1 is here, so then we have 2 edges, this edge or this edge. And this edge is now 3, and this edge is 5. So indeed, this is the one. Yeah, that's correct. And then for the order, I think I have to swap the X and the Z coordinate, the way I typed them in. Because it's still going to rotate this way. But no, I mentioned this. I mean, that does not have anything to do with the coordinates, actually, or does it? Well, that was Y. This, yeah, this is X. No, indeed, yeah, it doesn't matter. Well, the first one is X. Is the first one X here? That's a good question. Is this X or is this not X? The first one here. Ah, there must be X. So I think the order is still correct. But we have to start with, let me read it correctly now. Well, with this one, which I still, the reading is correct. I just had the lexicographical order wrong. So this is still 2, 2, 1, 0, is it? Yeah. Now it works. General reference test. Is that the last one? Oh. Yeah, if the only thing that changes is the order, and of course, I have no idea why would you return 3 times the origin, but you can change the order whatever you want. It's not going to change. So that one succeeds. And this one is then apparently by coincidence block empty. Okay, that is also absolutely not going to change then. And this I fixed and this I fixed. Yeah. Makes super much sense. So just this one's left now. A general reference test. Yeah, the problem is that this is using a reference thing, so it generates stuff. I don't have much control over that, except I could print it and then force it into the correct order, I guess. Or I would have to change or fix the reference. What is this getting passed? It gets passed a C1 and a C2. They look very const. That is the corners of my hyperblock and the plane. We use 4 different planes. It's more or less a random plane. That's not too bad. It just calculates all the intersection points and now I can order them. I do need, however, I do need to know which corners are part of all edges. Or do I need that? Do I really need it? Oh, this is way difficult. I think the first one is correct, because you start looking at the mask is 0. That gives us the 0, 0, 0 corner. And that means that as soon as we find an edge from there with the smallest possible d, and if that doesn't exist, the next mask with the smallest possible t. So yeah, the very first time you find an edge that is cut, that is the lexicographical smallest one. So the first one must always be correct. You can already test that. Instead of doing require same points, I can do could set the size of both to 1 and then call the same thing. Yep, the first one is correct. To find the next one. The next one. The next one. That's way too difficult. Let's ask the AI. It's too far away, so I would have to explain everything. Or maybe you can just do it in here. Switch the model back to GPT-5, not Codex. High reasoning. I need to fix the following function, test function, from an external test suite, not in this project. To return the correct order of intersection points. This already calculates all the intersection points, but not in the correct order. The first one that it finds is the well, is correct, because that is the lexicographically lowest edge. Minimal mask and D value. For which an intersection point exists. Please I'll suggest return code in the chat. It can be put before the return, such that the rest of the expected vector is well, has the correct order as well. The order can be determined as follows. Starting at the first point, rotate around the normal plane. Corkscrew rule, whatever. Maybe you should have told it what vector type is. Yeah, let's begin with checking what vector type is, actually. It was blabber. I don't even know myself. Vector type here. What the hell is that? It's a math vector. Does it have an eigen thing? Maybe it does have an eigen thing. Which means that it would have guessed that correctly. Math vector, that is this, yeah. Eigen, yeah, it does have eigen. I'm not sure why it is doing it like this. Probably was trained on eigen a lot. So it's easier for the AI to write this with eigen instead of just using my stuff. Because I have a lot of stuff here. Or do I actually? We have dot products. Yeah, this is actually not what I had in mind. I thought I had other stuff like doing the projection. Yeah. Okay, so it was in order to save time. I'm gonna give it the benefit of the doubt and just dump this in. And I mean, if it works, then it was correct. Return expected. Impressive. That is fucking impressive. Oh, wait a minute. I thought it was successful. Not impressive. Nice. I thought it was working. It's not red enough. Yeah, maybe it has to order exactly the other way. As in, I don't know. How do I reverse order? Probably removing this. Okay, it's not working. Just make the delta. Oh, I had expected something like that. Wasn't sure. Well, interesting. It's just a number of intersections is wrong. Maybe it forgot the first one. Huh? Oops. It's not my error. It's not my fault. Okay. Vibe coding. Just blindly copying what the AI says. Oh shit, no, I don't even know where it started. It wasn't that long. Yeah, this is where it started. Bing. Oops, I still get it. Yeah, the order is inversed in this case. Test these. 3, 2 minus a half. 3 times. Oh yeah, what? Oh! Oh! Oh, that is really funny. Yeah, brilliant. These are equivalent, so it just picks one. And mine picks this one. So it is cyclic. The order is still reversed. Damn it. Well, that must be the reason. However, if now I reverse the order, because I see the order is reversed, then don't the other ones fail? Confusing. Now it passes. Oh yeah, okay. This it fails, but it didn't stop or assert here, or no? Huh? Oh yeah, I'm skipping it. Never mind. So these have different size. Now it's 3, 2 minus a half, followed by that, which is the same as there, followed by that, followed by that. So expected has this one here. Mine returns that. Yeah, there's just this thing is here in the middle, which is a repeat of that one. No, I have that repeat as well. Oh, that's a repeat. This repeats twice, and here it repeats 3 times. That is the difference. One, 2, 3, 4, 5, 6, 7, 8. Yeah. Yep. Okay. But it worked before, didn't it? Now, who is the suspect here? Must indeed be my code then, because it used to work with this, and this simply returns. Yeah, maybe there's a round off errors here in play, but still, this code didn't change. Size of expected here was what it was. Or was it? Yep. It must have been my code that changed. Hmm. Totally possible, of course. Why the hell do I have 8 points? It's not even possible. The maximum number of points that you can cut a cube is 6. Ridiculous. So I think I should, if I remove the duplicates, then this is 6 and this is 6, and then everything is okay. Well, actually it's 5 then, because these are also duplicate. But then, well, those would also be collapsed, and then we have 5 left. 4 actually, because that is also the same as that one. Yeah, I have to think about this. I guess I'm gonna stop. Good night, if there's anyone left.